Question number 5. This question is of normal distribution. The lengths of western blue birds are normally distributed with mean 16.5 cm and standard deviation 0.6 cm. A random sample of 150 of these birds are selected. A random sample of 150 of these birds are selected. Part A is how many of these 150 birds would you expect to have length between 15.4 cm and 16.8 cm? A random sample of 150 of these birds are selected. Mean length is given 16.5 and standard deviation given, that is 0.6. A random sample of 150 of these birds are selected. How many of these 150 birds would you expect to have a length between 15.4 and 16.8 cm? First of all, uh, in this question, we have to find the expected number of birds from 150 birds having length between 15.4 to 16.8. First of all, we will find the probability uh, having length 15.4 to 16.8. This question is of normal distribution. We will write here x follows normal distribution with mean, mu and variance, sigma square. These are the parameters of the normal distribution, mean and variance. Sigma shows the standard deviation, but sigma square shows the variance of the data. So first of all, we will find the probability between that of length that lies between 15.4 to 16.8. In the question, mean length is 16.5 cm and standard deviation 0.6. So we write here x follows a normal distribution with mean is mean 16.5, 0.6 is standard deviation. We will take its square, but first we will find the probability that of a length lies between 15.4 to 16.8. We write here x lies between 15.4 and 16.8. We have to find this probability first. First, we will convert this x into z. X is a normal variable, but we have to convert it into standard normal variable by using this relation. Z is equal to x minus mu over sigma. Here z is a standard normal variable. We will first convert it into this x into z, so we may uh, have the value from the normal distribution. We check the value from the normal distribution table. First, we have to convert this x into z by using this relation. This will become x will become z, x minus mu over sigma. This will become 15.4 minus mu, that is 16.5 over sigma, that is 0.6. 16.8 minus mu 16.5 over sigma. We have to find this first probability, and simplifying these two, we get probability. After simplifying, we get z lies between minus 1.8 0.33 and 0.5. Now probability of 0.5 minus probability of minus 1.833, 0 point probability. This notation is called a phi, that shows used for this notation is used for probability. So we write probability of 0.5 minus probability of minus 1.833. Actually, this is a value of z, but that is not be negative. So we convert it into positive. So we will subtract it from 1. This becomes probability of 0.5 minus within bracket 1 minus probability of positive 1.833. After simplifying, we get probability of 0.5 minus 1 plus probability of 1.833. We get, now we from the table the value of probability 0.5 and probability of 1.833. From normal distribution table we get the value of 0 point probability of 0.5. Answer is 0.6915 minus 1 plus probability of 1.833. We get from the table, this will be 0.9666. After calculating these uh, terms, we get a probability is 0.658. Now, actually, we have to find the number, expected number of words, total number of words. A random sample of 150 of these words are selected. This is the value of n. 150 is the value of n. But from 150 words, we have to find the expected number of words having length between 15.4 to 16.8. First, we have found the probability, that is 0.658. Now, we will find the expected number of birds by using the this formula of general formula of probability. We know that probability of any event is equal to number of successful outcome over total outcomes. We have used these letters. NA shows number of, this is general formula of probability of any event, E for event. NA stands for number of successful outcome, and S shows the number of total outcomes. We Now we will put the values here. Total number of probability we have just found 0.568, and total number of words we have 150. It is given in the question statement. We have to find expected number of words. This means we have to find NA, number of successful outcome. Uh, Putting the values, we get probability is PE is, just we have found, that is 0.658, 0.658 NA we have to find over NS. It is given that N is 150, multiplying 150 by 0.658, we get this value will be uh, NA is equal to 98.7. But since the number of words cannot be in decimal places, we have two possible answers. Where number of expected words 98 or 99. Both answers will be correct. So final answer. We have expected number of words, and we can take from here 98.7. We will show here the value in integral. We will take the integral value because n never be in decimal places. So n can be 98 or 99. Both answers are uh, correct. The next part of this question is the lengths of eastern blue birds are normally distributed with mean 18.4 cm and standard deviation is sigma centimeter. It is known that 72% of eastern bluebirds have lengths greater than 17.1 cm. 72% of eastern bluebirds have lengths greater than 17.1 cm. Find the value of sigma. So again, we have now x follows normal distribution. Now the mean is in this question is 18.4 sigma square unknown. We have to find the value of sigma. Now probability is given. Now probability is 72% have length greater than 17.1. So we will write probability of x is greater than 17.1 is equal to 72%. Probability is given 72%. We will write here 0.72% means 0.72. Now again we will convert this x into z. X is a normal variable. We convert it into z by using the above relation x minus mu over sigma. So this become probability of z is greater than x minus mu over sigma. X minus mu is given 18.4, sigma we have to find is equal to 0.72. Now simplifying this, we get probability of z is greater than 17.1 minus 18.4 becomes minus 1.3 over sigma is equal to 0.72. Now this is the value of z actually that never be negative, so we convert it into uh, positive. So probability of z greater than this negative value or will be same as the probability of z is smaller than positive value of this. So we can simply we can say that we can write this relation. We can write this as probability z smaller than positive 1.3 over sigma will be same 0.72. Now we can here the sign is less than and the value of z is positive. We can write it as probability of 1.3 over sigma is equal to 0.72. Now from here 1.3 1.3 over sigma will be phi inverse 0.7200. We will take this value in 4 decimal places because in normal distribution table all the values of probabilities are given in 4 decimal places. So we are taking this value in 4 decimal places. From now we will uh, observe this value in a reverse order. We have to find the value of z against this probability. So this value will become from the table 1.3 over sigma is equal to this will be 0.5836 3. From here, by cross multiplying, sigma will be 1.3 over 0.583. Finally, we get the answer is sigma, that is standard deviation. We get this the 2.23 correct to 3 significant figure. 2.23 is the value of sigma. Now, next part of this question is part C. A random sample of 120 eastern bluebirds is chosen. Use an approximation. Use an approximation to find the probability that fewer than 80 of these 120 bluebirds have a length greater than 17.1 cm. This question is, since the word is use an approximation, this question is normal approximation to the binomial distribution. In this question, we will use the concept of continuity correction. So now it is given that probability that fewer than 80 or probability we have to find length greater than 17.1. So we have to find actually probability of x is less than 80. Now we will use here the continuity correction. X is less than 80. We will take the lower bound of 80, that is 79.5. Look, I am giving you an example to understand it. On the right, this is an example of continuity correction. If this is a general example, if x lies between 5 and 8, there is no sign of equality. There is no sign of, when there is no sign of equality, we will take the lower bound of first value, upper bound of this first value. We will take the upper bound of 5 and lower bound of 8. Now this becomes probability of 5.5 is less than x is less than 7.5. Now in this question, since x is less than 80, we will use the lower bound. We will take the lower bound. Lower bounds of this is called a continuity correction. Now we will make a continuity correction of x is less than 80. This will become, after continuity correction, probability of x is less than, we will 80 minus 0.5, that is 79.5 after continuity correction. Now we will use the same process. We convert this x into z by using the relation between z and x. This will become probability of z is less than x minus mu over sigma. In this situation, we will take this mu and sigma from the binomial distribution. So we have the information that n is 120, a sample of 120. This is the value of n. So uh, n is given, that is 120, and probability of success is, it is given in the question statement that 80% of 80% of these 120 bluebirds have length greater than 17.1 cm. So probability for greater than 17.1 cm is given in the part in the question statement. You can check this question statement is known that 72%. The probability is given of eastern birds having length greater than 17.1 cm. The probability of length greater than 17.1 is given, that is 72%. So we are taking here, because it is given that the 80 of these 120 bluebirds have length greater than 17.1 cm. Probability is given, that is 0.72, and q will be 1 minus p, that becomes 0.28. Now we will use here, now we know that in binomial distribution, in binomial distribution we will take the value of this mu and sigma from binomial distribution. We know that in binomial distribution, in binomial distribution mu, we get mu is equal to n into p. This is formula to find the mu, mean. Mu is mean value of the distribution. Mu is equal to n is 120 and p is 0.72. We get a value of mu, that is we get it 86.4. In the same way, sigma will be n into p into q whole under root, because sigma square np and q, and sigma is n p into q under square root. So we get uh, sigma is equal to n is 120, p is 0.72, q is 0.28. After calculation, we get the value of sigma is 4.919. Now we are using here uh, the value of mu and sigma in the question. So we get this probability of z is less than 79.5 minus mu, that is 86.4 over sigma is 4.919. Now we calculate this by using the calculator. We get this, uh, z is less than minus 1.403. Now we will make this value of z positive. We can write it as, z is probability of z is greater than 1.403 will be same as probability of z is less than negative 1.40. Simply you can say that if we change the sign of this value, then inequality sign will be changed. So we get this. Now we want to bring here the less than sign. So we can write it as 1. We are making this sign, that is greater than, we are making it less than. So we will subtract from 1 minus probability of z is smaller than 1.403. 1 minus probability of 1.403. Now we will check it, this value from the uh, normal distribution table. We get it 1 minus 0.9196. After calculation, finally we get it 0.0804, correct to 3 significant figure. This is the answer.